Welcome to Chapter 13, Module 2. We'll be talking about net present value for most of this module. You all ready, Sketch?
As always, I'm having a little net present value on that pizza I had last night.
I'm not sure indigestion can qualify as a net present value. More like a sunk cost, maybe? Let's look at evaluating an investment project using the net present value method. In order to properly measure one investment alternative versus another, we must convert both to today's dollars. We ask ourselves, what are both investments valued at in today's dollars? This puts the two choices in the same context, and it makes deciding which one to do much easier. To do this, we use the net present value method.
The net present value method compares the present value of a project's cash inflows with the present value of its outflows.
That difference is called the net present value. We are making two assumptions to help keep things simple.
The first assumption is that all cash flows other than the initial investment occur at the end of periods.
The second assumption is that all cash flows generated by an investment project are immediately reinvested at a rate of return equal to the discount rate. If we don't make these two assumptions, the present value calculation gets a whole lot more complicated. Let's work an example. Lester Company has been offered a 5-year contract to provide component parts for a large manufacturer. The details of the deal are as follows. The cost of the special equipment is $160,000. Additional working capital required of $100,000, and in 3 years we'll have to spend some money to reline the equipment. These three are cash outflows.
We think the equipment will have a salvage value in 5 years of $5,000. And the additional cash revenue and costs related to the machine are $750,000 in additional revenue, and a $400,000 increase in cost of parts sold, along with a $270,000 increase in salaries and other costs. These are the cash inflows.
These outflows and inflows happen at different times, so we need to use the present value method to bring everything back to today's dollars. A few more assumptions. At the end of 5 years, the working capital will be released and could be used elsewhere. This could be extra raw materials inventory used by the machine, which we no longer need when the machine's life is over after 5 years.
Lester Company's discount rate is 11%. That is their cost of capital, or the benchmark that they have set for an investment to be better than before they accept it.
Should the contract be accepted? First, we calculate the annual net cash flows from operations by taking the revenue and subtracting the expenses. For Lester Company, that equals $80,000. Next step is to list everything at today's dollars. Let's start with the things that happen today or at the start.
Investment in the equipment and working capital needed both occur immediately, so they are already at today's dollars. We use a discounting factor of 1.0 for these.
The annual net cash flows happen every year, so those are an annuity. So we multiply $80,000 times 3.696, the present value of an annuity factor of $1 for 5 years at 11%. Remember, that the 11% is the company's predetermined discount rate.
The annual net cash flows in today's dollars is $295,680.
Next up, let's calculate the cost of relining the equipment in today's dollars.
We think that cost will happen at the end of the third year, so we multiply the cost of $30,000 by 0.731.
0.731 is the present value of a single amount paid in 3 years using an 11% discount rate. In today's dollars, the cost of relining the equipment in 3 years is $21,930. The salvage value and the working capital released both happen at the end of the life of the equipment, so we multiply those amounts by 0.593, which is the present value of a single amount for 5 years at 11%.
Now, everything is expressed in today's dollars, so we can just add up the inflows and subtract the outflows to calculate our net present value.
Our net present value of the investment opportunity is $76,015. Since the net present value is positive, it suggests making the investment. Let's look at another way to calculate the net present value. Let's take the same company, assume the same 5-year contract to provide parts for a large manufacturer, and we have the same assumptions of cash flow as before.
Same as before. At the end of 5 years, the working capital will be released, so that would be a cash inflow. The company uses a discount rate of 11%.
That's probably their cost of capital, so to accept a contract, they need to earn more than that. Let's see if they should accept this contract. As before, let's reflect the immediate cash outflows first. Then we could reflect the net inflows or outflows for each year.
Notice how the annual cash flows are reflected as single cash flows for each year. Notice that we would use the present value of a single amount for each amount instead of using the annuity factor.
You can also see that in year 3, we have a cash inflow of $50,000. This is the annual cash inflow of $80,000 less the outflow for the equipment relining of $30,000. As you might have guessed, this gives us the same answer as before. So you can use the annuity factor for even amounts received over several periods, or you can use the present value of a single amount for each year. Both give you the same answer. A positive net present value indicates that the project's return exceeds the discount rate, which means we should probably accept the project.
A negative net present value indicates that the project's return is less than the discount rate, so we should not accept the project.
So we accept the positive net present value project because it suggests a return greater than the required rate of return.
And we reject the negative net present value project because it suggests a return less than the required rate of return.
A company's cost of capital is usually regarded as the minimum required rate of return.
Cost of capital is defined as the average rate of return a company must pay to its long-term creditors and shareholders for the use of their funds.
If we want to invest in a new machine, we want to make sure it will have a return greater than our cost to have that cash. Otherwise, it just isn't a very good investment. So the cost of capital serves as a good benchmark for investments to exceed when we're looking at their net present value analysis. Keep in mind that the net present value method automatically provides for the return of the original investment. We're interested in measuring how much above the original investment we would be getting. Carver Hospital is considering purchasing an attachment for their X-ray machine.
It has a cost of $3,169, a 4-year life with no salvage value, and will increase annual cash inflows by $1,000 per year.
We need at least an annual return of 10% to justify the investment. Should we do this or not? If we list our cash flows and then reflect the present value of those cash flows, we see that our net present value is 0.
This implies that the cash inflows are sufficient to recover the investment and also to provide exactly a 10% return.
Net present value method takes into consideration the recovery of the initial investment plus a return at least equal to the discount rate. Hey Sketch, let's wrap this module up.
I'm thinking of ordering another pizza as soon as I calculate the net present value. Cash out now, tastes great in 30 minutes, and indigestion in 2 hours. Sounds like a smart investment to me.
Only in college is that considered a good investment.